Hello everyone and welcome back. So we're going to continue to work on our chocolate break scene. Today we will start on this filling, the cream inside. I'm not sure how much we will accomplish, but let's try not to make the video too long, because otherwise people don't even bother to watch. So we have this animation so far, and now we will start to create the inner filling. So we're gonna isolate these frames first. So let's create in here a blast, and let's delete non-selected and interior break. Then we're gonna create a null that we might need to reference for later. And right away I'm gonna switch to the second UV that we have, so these UVs in here. So let's switch to that with an attribute swap. And we want to move on the vertex the UV2 to UV. So now we have these UVs. Let's create another node that we might need for reference, and after that I'm gonna split one of the frames. So let me see, split, and it will be at class is equal to 0, and make sure you set it to primitives. That's fine. Then we're going to time shift this, and we're gonna set it to $F start. So for the beginning of the animation. All right. Now we're going to scatter a bunch of points, but I want to have a margin in here. So we're gonna create a copnet. And in this copnet, I'm just gonna import in here from this null. Before we do the attribute swap, I'm gonna time shift this. And I'm gonna time shift to $F start. Oops. And we're gonna create a null and name it to cops, because I want to scatter this in texture space. So let's copy this, and in our copnet, let's sop import and use external sop. That's fine. Then we're going to rasterize setup and move it to the UVs, and I'm gonna import UV2, and it's far away. So, oh, it's in another tile. That's fine. We can create a layer, and default settings will be fine. And we'll do match UDIM. And I think this is UDIM 1003. And then we're going to rasterize setup. Rasterize geometry, I mean. We're going to connect these in here and these in the camera ref. Well, it's not UDIM 3. Let me see in here. So this is UV, UV2, 1, 2, 3. So that should be fine. Why is not working? So match UDIM, layer, rasterize setup. Let me see. Okay, this is buggy. Oh. So rasterize setup, rasterize G. Oh, that's fine. Then we just want to erode it a bit on this alpha. So let's do dilate, erode, and I'm gonna erode it by 5, so -5. So we get something like this. It's not much, but anyways. Let's create a null and name it out mask, and this is going to be our mask. Let's copy and let's create a scatter. So let's create a scatter. I'm gonna scatter 2000 points and we will do it in texture space. Sorry, not 2000 points. We want to scatter 2000 in density, and as for the texture, we will use OP and the path we just copied. Oops, I didn't copy. So let me go back and Control C. Control C in Houdini is buggy as hell. So let's do it. OP Now that's fine. And let's make sure we scatter on here. And for good measure, we can add spare input and connect it to here so we know it's related. So of course it's not always working, that's fine. Now we can try to relax this quite a bit, but it won't work very well. So our best option is to relax in another operation. So let's do for loop with feedback. Let's distinguish these. Let's connect it to here. And I'm gonna create in here a circle. So let's create a circle. I think in here I'm going to create the rounded shape. So I want these points to go from this shape that we initially have to a rounded one in the middle. So we need to save that state, let's say. So that's the first operation, and then we will do the relaxing of the points afterwards. So let's create a circle. I'm gonna set it to XY plane, that's fine. And let me connect it as a spare input, this scatter that has the bounds, and I can do in the center. Let's just change the uniform scale to 0.15, which is about the scale of these. And let's do a center of centroid -1, which is the spare input, the X. Let's do the Y, and let's do the Z. So we have it about the same position, and let's do 32 divisions, that's fine. Now, inside the loop, we're going to use a relax, not this one, relax, point relax. And let's connect these in here and connect this one to here. And we're gonna do a point radius scale of 8, which is a value worked fine for me. I don't want to use B scale because I don't have it. And then we just do this for a while, and let's do 24 for good measure. And we have this perfect result, as you can see. That way we can mix this initial shape with the rounded one at the middle. It will make more sense in a bit, so let's not rush things. So now I want to create a group for the center point. So for that I'm going to create a wrangle. I'm going to name it center PT. And this is pretty simple. We just get the bounding box center. So get b box center of the incoming geometry. Then make sure we set these two details since we just want one point, and we do int near point will be equal to near point of the incoming geometry, and the position will be the center. Then we just set point group because we are in a detail wrangle, and we do 0, and let's name it center. The point is near point, and we just set it to 1. And now if we copy this and visualize it in here, we should have a pointer somewhere in the center. I guess that's fine. What else are we going to do? We're going to create a direction vector. So let's create a wrangle. I'm not sure I'm going to use this, but just in case. So we're going to do v at there. It will be equal to normalize from the center. So get b box center minus v at p. Now let's visualize that. So we already have a visualizer. Let me increase maybe the scale. So we get this vector pointing at the center. We might need this, I don't remember honestly, but anyways, let's keep it. Now, what else are we going to do? We are going to work on this geometry. So let's create a wrangle in here. So this is our initial geometry, but we want to copy some stuff from here. So mainly, since we have the same point count and point IDs, we can copy from the second input position, and let's call it vector at orhp. It will be equal to v at op input 1p. So we just want to copy the position from the second input, and we also want to copy the dir. So v at op input 1 dir. And we also want to copy the group. So let's do I at group center it will be equal to I at op input 1 group, that's the syntax, and let's do center. And yeah, we have the direction, we have the original position, and what else? We have the group, I believe. So yeah, let's just visualize that. Yeah, we have that center point. So we successfully copied everything we needed. So copy groups and attributes. Now we're going to do the same we did above with that for each feedback, for loop with feedback. So let's do a for loop with feedback. Let's color this something like this. Let's create a point relax. And we want to do it based on a null I have in here. So after the time shift, I should have created a null in here, yeah. So let's create a null in here. It will calculate again the for each. So let's copy this and let's paste it in here. So this is the shape, and we're going to relax it based on this, and we need to change a few things. So in this case, I'm not gonna use p-scale and use a point radius scale of 0.15. Let's see, 10 iterations. That's not good enough. I'm gonna set it, let's see, 12 maybe. That looks a bit better, but as you can see, our edges won't look as clean. So my file told me something different, but in this case we can just reduce the point radius scale and we get this almost perfect result. Okay, and 12 iterations, maybe we can get away with 10 only. Yeah, that's fine. Now, what else are we going to do? We're going to make sure, in this case it's not happening, is it? So I want to make sure this boundary is fixed and it does not have points from the inside going to the boundary. So I'm not sure it's needed in this case, but let's just do it anyways. So I'm gonna duplicate this and group the unshared. And I think I did it on the edges. And we're gonna set it to edges. We're going to convert line to get the boundary. So unshared, connect path. We're going to fuse, just in case. And we're going to attribute delete everything. And then a simple resample. And let's see how much did I use in here. So quite a bit, 0.002. And we might need curve view. So let's do a sweep. Oops. And we will set it to ribbon and 0.1. And make sure we set the axis to be y-axis, so something like this. And we're also going to do a very small peak, so about minus 0.0005, so just a little bit. And then we're gonna organize this a bit and do another wrangle. So a lot of wrangles today, as usual. And we're gonna set this to fixed boundary, because we also want to create a mask, or in this case a group, from this wrangle. So let's create, we'll use the intersect function, so we need to create some vectors first. So vector I pos, this is the target position, I EOVW. Then we're going to create an origin, so it will be equal to the current position. Then we're going to create a direction and multiply it by a distance. So this is for the intersect function. And for the intersect function, we can do int I prime will be equal to intersect the first input from the origin along this direction. And we're going to save I pos and I UVW. Then we're just gonna set a mask. So I mask, it will be equal to I prime, not equal to -1. And of course I did a mistake in here, so we need to vector there. It will be equal, oh, then we need that there. I thought we didn't need, but we need. So let's create a distance of 0.0015 and let's check that mask. So, let me see what we have in here. Let's set it again to, let me see something. So we will have to improvise in here. Let's set again that to a small value. And let's play with the peak maybe. Yeah, that will work. So just reduce it a bit, that's fine. So we want to create this mask for to use later. And we also want to create a group. So I add group boundary, and it will be the same, I prime not equal to -1. And if we check that group, that will group those points, that's fine. Let's get rid of these. And we're also going to set v at p is equal to I pause to make the boundary more clean. And we're also going to set a sort attribute. So f at sort val will be equal to the curve view. So prime uv 1 curve, curve view, and we're gonna use the I prime and the IUVW that we get from the intersect function. Let's look at that sort val, and I might as well remove the group because right now I don't want, and we have a value from 0 to 1 on the boundary that we will use later. So after all this is necessary, we just had to play around with it a bit. Then we're going to do a small fuse just in case we have some overlapping points. In this case it's not doing much. Let's maybe grease, yeah, just in case. And after this, we're just going to sample the UVs. So let's do another angle, and we're gonna call it sample UV and set ID. And we're going to connect these to this node in here. So let's move all of these right now. Oops. And connect these into here. And now let's sample those UVs. So let's just set V at UV, it will be equal to UV sample. We just want to copy the UVs. First input or second input, we want to copy the UVs using the position and the current position. Let's just see how that looks on the UVs. So that's fine, it's working. Then we want to set an ID. So I at underscore ID, it will be equal to I at pdna, because I think we will need that. Then finally, we can mirror this. So let's go in here, and after the split, we can create another null in here. So this is for the second shape. And we can create another angle. And let's say mirror point. Let's set this to this color. And connect these in here. And let's do the following. So, am I doing this right? So let's set V at P will be equal to UV sample, second input, and we want to go copy the position, and we will use the UVs because we have them on both streams. So V at UV as a sample position, and we get the second input. So now we just can merge it. So merge and copy these in here, and there we have. And yeah, I don't think we want the animated, so we want the time dependency, so that's fine. Then we can do an add, And let's make sure we not visualize any attribute, just in case. Maybe reduce this to 3. I have this by default. And now we can do polygon by group and by attribute and underscore ID. And there we have the beginnings of our filling. Okay guys, now we have only these points at the beginning at the end, so we need actually to resample these. And we don't want based on length, we want a fixed amount because we have this animating geometry. So this way we keep point consistency. And now we're going to create a rest because we will need it for shading, and make sure we add a rest model, a rest normal attribute. And we're going to do just a time shift in here. And this is going to be based on the end frame, and just add it in here. So now we have a rest attribute and rest normals, which means we can do an attribute noise, let's say noise A, just for testing. And let's visualize it, and we can decrease the element size. As you see, this one is swimming a bit, so what we can do is to do it based on the rest. And now, as you can see, it's stretching. It's not in wall space. It's stretching with the shape, which is what we want for shading later. Let's create a custom ramp that we will need. So let's name it custom U mask. And this is like a curve view. So let's do float U. It will be based on relative point bounding box 0 P at P, and we want the Z position. And then we will assign it to an attribute called U. And let's visualize that. So U, it's just a mask going from left to right along the Z-axis. And now we want to mirror this. So for that, I'm going to create a mirror effect, which is just 1.0 minus absolute U multiplied by 2.0 minus 1.0. Now we should have this mask. Let me see if that is working as well as my original file. We want the red in the middle, yes, so that's fine. Now that we have the mask, we can create in here a null. And now we want to do some transformation to this, so we can start to apply this deformation that you see in here. So going from the original shape to this rounded one in the middle. So let's do that. Oh, I shouldn't have closed that, but anyways. So let's move this geometry to the original position. So attribute triangle. We want to move this to the rounded shape, so we should have that attribute. So ORHP, yeah, it's in here. So move to ORHP, and we will do, first of all, get the bounding box center, get the box center. And we also need to get the center point of each prim, so we can do the proper transform. So vector center curves, it will be equal to prim UV 0. I want to get the position of the I at prim num of each prim, and we want to grab it from the center, so 0.5, 0.0, and 0.0. You can just input 0.5, it will work fine, but this is a vector, so it's a good idea. We do this. Why is complaining about? So prim UV. Sorry. Vector get. Oh, we don't actually need this, so we can just get rid of it. But I was missing the variable name. So now we want to do v at p minus equal enter curves. So that will move all the curves to the center. And then we can do v at p plus equal v at origin p. I should have give a better name, but anyways. And now we get the rounded shape. So now we need yet another angle. So this one will be center core curves. And we will get the second input from here. And let's see what we will do in here. So right now we actually need the bounding box center, so let's do vector bbox center. Let's not forget the variable name. Get bounding box center of the first input. Then we will get the vector bbox center myself, which will be get bbox center from ourselves, so the first input geometry. Then again, we will need the same as in here, so center curves. Let's copy from here and paste it in here. Then we can do center curves minus equal bbox center myself, so from the first input. And then we can do v at b minus equal bbox center myself, and that will move it to the center. We needed to subtract from the center curves that one, because right now we will do v at b minus equal center curves multiplied by a channel called dist. We just want to shrink this down. And if we do that and we start to increase this, and let's do 981, we get the what will be the inner part of the filling. I'm calling it filling. I don't have a better name, but it's like the cream inside. And then we just want to move it to the B box there. So now it should be in the same position, as you can see, and with the same size. So now we need to do the other part, which is interpolating this and creating the animation. So let's create in here a null. And let me press Z and change the C. Let's call this rest anim. And we will finish just after this for today, but it's still a bit so deformed. Still some work we have to do in here. So let's create a last triangle for today. And let me save this, by the way. And this will be the form stretch. And that's fine. So now we want to blend both shapes. So we have the, let me get rid of this visualization. We have the original shape and we have the inner part. So let's first of all create a bias, because we were going to use a lerp. So it's just like a mix. Just call it bias, ramp. And it will be based on that U mask we created. So let's call it U remap and F at U. Not F at U, sorry. So let's create float time, since we're going to animate this, and it will be a channel float all time. Then we're going to create the animation, so float anim, it will be equal to fit, and we will fit time between 0, and in this case I chose 1.8 seconds, and from 0, let me just be picky and set it to 0 0.0, 0 0.0, and 1.0. It's fine. Now we're gonna remap that, so chramp, since we wanna retime it. And let's pause there and create this and do at time. And we will create the remap of the animation and the remap of the curve view. But for now, let's just continue by creating in here. So let's see, bias multiplied equal by the anim plus an amplitude. So we want to use the animation as from the curve view multiplied by the animation. So curve view, or U in this case. And we want to scale it a bit. From there, we can just lerp. So v at p will be equal to lerp between the current position and the second position. So up input 1p, and we want to use the bias as our blend amount. So what am I doing wrong? Local variable time not found. Okay. Float time, what you're talking about? I have time in here. Oh, sorry. Time. And now if we have a look, this doesn't look like much. V at up input 1p, because we actually need to play with the amplitude. Where is that amplitude slider? Because I should have created. Okay. Now if we have a look, it's doing something like that. I'm gonna set this to 0.991. So it's creating this, but now we need to play with the fall off. So instead of me typing the values of the ramp, I'm just gonna copy from my original file. So I'm gonna set this to manual. And it's not this one, sorry. It's this one. So I'm gonna copy. And let me just copy this U ramp to here. So paste values. And let me copy my animation copy parameter and paste it in here. So if we enable again, you can see the difference. So let's see. Now it's creating the desired effect. I'm just retiming in here the animation, so it starts a bit slow, ramping up, and then it goes slowly at the end. And I'm just remapping the U so I can shape the shapes, the geometry. So let's create a null and delete this. And now we can actually visualize this and look at our final result for today. So we have something like this. So again, guys, I hope you have enjoyed. If you want, you can grab the files on my Patreon. And please let me know in the comments if you want me to keep pushing on this project. This is already made like 4 videos on this project. As you can see, the network is already quite big, and we have done everything step by step. Again, I always like to hear your comments on YouTube or on Patreon. So if you feel like I should have done something different, or you just want to comment on this project, please let me know. And other than that, thank you for watching, and I guess I'll see you next time.